We're going to go ahead and get started. Go through the intro. Welcome to today's BSUG. The topic is using the Energy Resource Library to benchmark buildings. So for those of you unaware, we're the Integrated Design Lab. We are growing, and this picture will look better once I get some headshots from the new employees.
Yeah, go back to one. Because sorry about the doctor's update. Now and very excited to be part of the team.
So we are dedicated to the education, outreach, and technical performance for energy efficient building design in the Intermountain West. I'm going to skip this one because that's what we're talking about today, as well as BSUG. That's what we're having now. But next month, we're doing a joint session with ASHRAE. We hope to have it be a panel-style discussion on HVAC loads and calculations. And after that, for November, we plan on talking about CVEX 2018 data and trends that we've been working on this year. So pretty excited for that. Also this fall, we're doing an energy codes for Idaho lecture series. This is a QR code. If you want to take a moment to scan it if you want, or you can come back and watch the video when we post it. It's basically a survey to kind of ask you about what you feel about code, how familiar you are with it, how comfortable you are with it, what parts of the code confuse you that you would like, a detailed explanation or an example of. So some of those things, just respond to that and give us feedback so we can tailor it more towards your needs. Next, we have technical design assistance. This is broken out by scope of work, depending on whether it's less than 2,000, between 2,000 to 4,000, or greater than 4,000. Level 3, greater than 4,000, that's cost share agreement. 75% is covered by Idaho Power, 25% is covered by you or the owner, however you want to work that out. This is a service that's paid for by the Idaho Power Company. You can call me up and ask me about a tool in the Energy Resource Library and how you can potentially use it for a project you're working on. Or you can ask me about a software feature or a code standard or something along those lines. That would fall under phase 1. Phase 2 is more of like we have a scope of work with you. It's not intense, but we're going to help you organize, create a plan, do some simple energy box modeling, maybe daylight analysis, things like that. And then we have the Idaho Power Commercial and Industrial Energy Efficiency Program. I don't know why that slide title got messed up. That's really bugging me. But anyway, Shree, would you like to talk on that at all?
Yeah. So it looks like we have 13 people online, right? Is that right?
Probably, I'm kind of blind right now.
Okay. Yeah, I was just thinking the people in the room kind of know about our program. So if we didn't have a bunch of people online, I probably wouldn't. But we have energy efficiency programs for new construction, major renovations, retrofit, and then custom as well. New construction, major renovations, and retrofit are prescriptive programs. We tell you up ahead of time. If you do A, you get B incentive. And then anything outside the box or that we don't have a prescriptive measure for, then we possibly have a custom. And Andy and Curtis are in the room, and they run our custom program, also with Chris Paulo, and I run our new construction and major renovations program. So if you've got a project, just reach out to us and we can talk about it. Go back one slide. I do want to remind you with the new construction and major renovation program, we do offer a professional assistance incentive, which is equal to 20% of the customer's incentive up to $5,000 per project for the architect or engineer that helps the customer with the paperwork process to get that incentive, the application and supporting documentation. So if you are an architect and engineer, take advantage of that. Or if you're a customer or owner that works with an architect or engineer, have them help you out with that process.
And that's not deducted from the customer's incentive.
Correct. It's an addition. Yep.
Okay. And for those of you not in Idaho Power territory, not an Idaho Power customer, I encourage you to reach out to your utility. They probably have an incentive program of their own, as well as representatives that are in charge of dealing with the incentive program. So for our online folks. Okay, so today's lecture, let's talk about the Energy Resource Library. So this is a collection over 900 building diagnostic tools, primarily focused on energy efficiency or electricity. So kind of limited if you have anything gas related. Talk to Intermountain Gas about what they got. So anyway, anything that kind of diagnose or measure the performance of a building that deals with electricity, we generally have that. And so this is a free resource that you can check out if you are an Idaho Power customer. For those of you not in the immediate Treasure Valley, say you're in Sun Valley or a little more out to the east, you can still borrow. We will ship the tools to you, but you incur all cost of shipping, unless it's a specific Idaho Power project or whatnot, then they can kind of get indexed under there. But you are responsible for shipping the tools to you and shipping the tools back to us, okay? So, how do I use the Energy Resource Library? So you navigate to, yes, it's fine. So this is our website, idlboise.com. Under it, we have, on the tab right here, Energy Resource Library. The link I have leads directly to our categories. But here's our landing page, kind of explains what I'm about to talk to you about right now. Just through the process. So you do have to have an account with us. So you're on here, you have to be able to sign in. What the sign in allows you to do is we've arranged the library to kind of be like online shopping. So we have organized our categories. So you can look at specific different ones, but you have this add to cart feature. So the tool you want, you have to sign in, get the account, that gives us all your information and whatnot. And then you have a shopping cart. So let's say we want to do this, we go to view cart, and there's no checkout button because we have to sign in. So in order to complete the checkout process, you have to sign in to your account, which is free. So the library is organized by a couple different categories. Temperature, data logging, flow meter, sound reading, energy, air, thermal cameras, lights. It's pretty straightforward. We have literature in there if you want to look at certain standards or guides or best practices for building types or schedule and operation, current transformers, things like that. And so from here you can click on and it will bring you down to the individual category, what you're going to be able to find in that category. If it's not straightforward, this one obviously is. You're going to click here, and this will tell you basically just a little more information than the last viewing page we were on. That's kind of like you're a returning customer to the library. You know what tools you want. You just want to throw them in your cart. If you're new a customer and you want to know what it measures, how it measures it, the accuracy, if there's a subcategory that's linked to it. So if you want to look at all the cameras or just all the accessories, we're organized by that. So we have our main categories and we have subcategories. And so you can kind of see everything associated with that. So everything's kind of linked in through that vocabulary. And if you go to read more, it'll take you to the tools landing page itself. It's going to give you the model. All the tools have a manual with them. That's the manual we got at the time. You update them if applicable. We also have hard copies of these manuals if you want to have one for yourself. But we have the PDF available so that you can just download it and have it on your phone or whatnot for when you're using the tool. And yeah, it gives you a longer description, how it's operated, external power operations, battery type, things like that you're gonna generally need to know about the tool. Probably, let's see. Let's go with energy. So this is probably a better one. So power logger. We got a couple different, we got a quick start guide, we got a user's guide, and then we got the data sheet. So that's how you're pulling data off the logger and how to process it through the software. So that's kind of a barrier that sometimes happens is that, you have the tool, you're using it, and you're done, you collect data. Okay, I'm struggling with the software. Okay, so don't give up. That's part of my budget is I have hours that I give for technical support. Okay, so sometimes some of the tools can be a little bit older where the software program is a little dated and hasn't been, kept up to date. So say you have How is it? Are we on Windows 12 or 13? What are they on now? I don't know. I always just use what's here. But recently I had a user not be able to connect to a logger that he had, and it was because the software program was incompatible with the operating system. So we had to do a workaround in order for him to get the data off. Normally, when I run into that kind of problem, I'll just do it myself and give you the data because that's the best easy use. But this was going to be an ongoing project, and so that wasn't really viable. But so generally there is a workaround, and I'll find it, and we'll get to the endpoint and get you the data that you need. Yeah, so that's kind of the Energy Resource Library. The website, there's also an FAQ. We have COVID and pre-COVID, so currently we're post-COVID, so I'll probably need to update that, but it's still pretty accurate. So if you have any questions, you can come to this page as well. All right. The next common question I get asked about the library is how long can I borrow resources that I checked out? Well, that kind of depends on what you're doing. If you're logging data, let's say it's a pump or a fan or an HVAC unit or whatnot, a couple days, that's not going to cut it. We need some good quality data. We need to, be able to see trends and observe how the equipment is operating different times of day, different intensities, different scenarios, things like that. So depending on how the longest, I think I've checked out something is 9 months. That was just a continual log, grab the data, log again, grab the data, log. So it varies. I've had tools, checked out for 1 day, return the same day. They just need a thermal camera, and they take a couple images, and they're good to go. So it's really up to you. You do have to specify when you're checking out alone the date and the time that you want to pick it up, and then you just specify the date that you would like to return it. Another scenario is, hey, we got a little bit of late start, or something happened and we had to reschedule the site visit, so I kind of need to borrow the tool a little longer. That's completely fine. Just gotta let me know, give me a call, send me an email, and I'll extend your loan. That's very common.
Do you ever have the issue where somebody wants to check something out, but you don't have it because somebody else has it?
Usually the only time I have the problem with thermal cameras, they're pretty popular. For everything else, we keep a decent quantity on hand, just because we don't know the scope of the project. So if it's a 3,000 square foot building, or if it's a 15,000 square foot building, you're going to need, more sensors to deploy into the building to monitor. But that is something I do make a note of when loans are extended, is that the IDL reserves the right to ask you to return the equipment in case someone else wants it or needs it. And so I also done it before where, hey, I need this piece of equipment, so-and-so has it. I know it's going to be back in a week and a half. I'll call that person like, hey, week and a half, how solid is that return deadline? They're like, yeah, I can meet it. Okay. They'll talk to the other person that's requesting the tool. Hey, it's available in a week and a half. Does that work for your schedule? So always try to make it work. Haven't had a problem with that yet. So for how long do you have to wait? I generally ask to allow 1 to 2 business days, just because the size of the order can be pretty big. Someone could have it out. We're using it on our own site visit, so it's not available. However, if you call me or send me an email after you submitted your request and you need it same day, I can make that happen. I just need the notice. So if you make a request same day and you don't send me an email, or you don't hear back from me at all after you have, and you show up to the lab and you're like, what do you mean you're doing here for this? Well, I don't have that tool ready, sorry. So just keep that in mind. Pretty flexible, just as long as you give me a heads up. Here are the 12 categories that the tools are organized by. And then we also have 4 kits. So we have the lighting analysis kit, the indoor environmental quality monitoring kit, with their efficiency, electric, gas, and rooftop HVAC monitoring. So a toolkit from the ERL is just a trend that we've been seeing over the years of, hey, these tools are constantly checked out together and they're constantly used for this purpose. And so we kind of compiled those together. And so rather than going to find the individual tools, you're like, oh, I need to do lighting analysis. So then you just click and you add the entire kit. And so that has its own page right here. There's a landing page. It's going to tell you about the kits, and then you can click on one of these. Will tell you the typical uses. Okay, so here's so this is intended generally for people they know a problem they have. Like, we got a problem with the lights. There's glare. It's too bright. It's not bright enough, etc. What do I do? Just add the lighting kit to your cart, and then here's your typical uses, what tools, it links to their individual page, so if you want more information on them. But we also have developed setup guides. So this is the lighting toolkit. It's going to tell you, the purpose, what's on the web page that I just showed you, what to use it for. Meet the tools, so it's going to tell you about each of the tools that's included in the kit. Typical usage, it's going to give you a general idea of where to start with the tools and why. Best time for data recording, depending on your scenario, which you're logging. It might be better under certain conditions than others. For example, high summer or high winters, generally when you want to take thermal imaging for your envelope of your building, that's where you're going to see the most contrast of it. But that's not to say you can't do it in the spring. But things like that, tips and tricks on what to remember for using the tool and logging it. FAQ, so some things that might be you're not familiar with, saying the difference between lux and a foot candle, illuminance versus luminance, things like that. And then it goes into each individual tool and breaks it down. So all the information you're finding in this is we just pulled from the manuals and kind of repurposed it and cut out some of the more technical jargon and reworded it. And so this is for all of them. So complete setup and everything, how to do it, and whatnot. And of course, you can always call me and ask me for help, and I can actually we can arrange either when you pick up your tools or at a separate date. I can run you through and show you how the tool operates and things like that. Okay. Any questions so far on the ERL kits?
Your boiler efficiency kit, I know you mentioned this is primarily focused on electric. Is that only for electric boilers, or does this work on natural gas?
Only electric.
There are elements of it that would be applicable to a gas boiler too, flow and
Temperature sensing.
yeah.
Surface temperature, air temperature, things like that. The thermal camera is also applicable. So things like that, but nothing directly to how much gas is going in, the pressure of it. All right. Yeah. Okay. So now let's get into benchmarking and auditing. So audit, an official inspection of an individual organization's accounts or assets. For us, we're talking about energy efficiency and building energy demand or consumption. So benchmarking is the practice of comparing business procedures or performance. We kind of know them as best practices or workflows, and kind of comparing them across the industry and seeing, which rises to the top. Generally, we don't say audit anymore, at least at the lab. We say assessment. Audit generally has a lot of baggage to it, particularly because of the IRS. So people, they kind of think, oh, I've done something wrong. You're gonna, go through my books and, break it with holes. That's not at all the point. So we generally try to say assessment. We're just kind of taking inventory or taking stock of the current performance of the building. The reason for it is we're trying to identify energy efficiency measures. So opportunities to improve efficiency throughout the building, whether that's equipment, scheduling, set points, control strategies, things of that nature. In addition, you also want to work with your local utility provider. They have what do you guys represent of what? Energy? What's it called? Your Idaho Power customer reps deal with
Energy advisors.
Energy advisors. That's cool. So talk with them. They have incentives for it, as well as if you go above and beyond and you can prove that you are going above and beyond your energy efficiency, then they offer custom incentives as a case-by-case basis. So work with your energy advisor from the utility company. So why should you benchmark? In 2016, the EPA found that buildings that were benchmarked consistently reduced energy an average of 2.4% for a total savings of 7%. So consistency is the key word there. That doesn't mean you have to do it every 6 months or every year. You can do it on a bi-yearly or every 3 years, but it just needs to happen, and so you get the data point. And once you do the first one, all the rest are easier because you have all the legwork and everything done. You're just updating the information. And the reason for the white sheet is the cost savings throughout the building lifespan. So energy efficiency, reduced maintenance costs, informed decision making for equipment upgrades, and improved occupant comfort for productivity. So energy efficiency, that's pretty straightforward. Savings captured from reducing your overall overhead cost of operating the building. Reduced maintenance costs. Energy audits will allow you to tag and monitor potential problems, as well as if anything kind of goes out of a certain margin of error for performance, you kind of know where to start looking right away. And so that helps you save you time. And then say, something breaks, something no longer works, you now have that to make an informed decision to upgrade the equipment. And say you make that, make that nice purchase, you got an incentive kickback for it. It's been operating for 6 months and your utility bills aren't reflecting that. This is one of the methods you can do to verify that and try to figure out what the problem is. Improved occupant comfort for productivity. We all know everyone is more productive in an environment they are comfortable in, okay? And if they are not comfortable with it, they will do whatever they possibly can to make it comfortable, and that can be detrimental to energy efficiency. So we always want to make sure that the space type is serving the occupant and then energy efficiency. Because if you do the first, the second one's going to follow. So there's typically 3 phases regarding energy audit or benchmarking. You got the process, you got the reporting, and then you got the follow-up. The last step is, in my opinion, one of the most important, is to follow up. And then it's basically you just rinse and repeat. You're setting a target, you're evaluating your progress, and just keep going. So energy audit tasks. So it's energy audits according to ASHRAE, which is like kind of the leading standard for energy audits or benchmarking. They break it up into 3 levels, 1, 2, and 3. And so the first one is conduct PEA, preliminary energy assessment. Then you have the actual walkthrough survey where you're walking through the building and you're documenting. Identify low cost, no cost recommendations. Probably one of the more straightforward ones is, replacing incandescent with LED or compact fluorescent with LED. Actually setting the thermostat set points universally, having a lighting setback schedule, things like that. You can walk through and observe, no problem. Capital improvements would be something like, hey, none of your spaces have occupant sensors. You could save, X percent if you install occupant sensors. So that's a capital improvement there. And then level 2 gets a little more in depth. This is typically kind of what I recommend is a level 2. A level 3 is you're going for a standard or certification. So you need that much data, or you're investigating a known problem and you're trying to diagnose exactly what is the issue. So level 2, you're reviewing mechanical and electrical design criteria, seeing the zoning, the unit operating on the appropriate schedule, have the setbacks been changed at all, things like that. That get kind of more into key parameters. So are your light levels, consistent throughout, or are they varying? Yeah, you could get into a lot more of that in a bit.
Quick question on the, we could look at that. Yeah. So the level 3 is that's compliance modeling for typical certifications, LEED, passive house.
Another one would be you're doing non-prescriptive compliance, so you're submitting an energy model for review.
Gotcha. Okay.
Or you've done a major renovation or retrofit, and you're going for a custom incentive, and so you have to, see the exact percentage or the exact amount of kilowatt hours that you're saving.
Okay.
Things like that.
Yep. Okay. Thanks.
For me, I think that one is like a general overview. 2, you're starting to get more detailed on the cost side, and 3, you're starting to get more detailed on the predicted savings side where you're doing the modeling.
Okay.
So 3 has that modeling component. two has that costing on it, and one has that just that overview.
And so between 2 and 3, is there a level of analysis particularly with the layouts for like thermal comfort and different
Yes.
like that?
So the report side of it, so the amount of data you collect is going to inform the amount of reporting you can do and the level of detail that report can have. So level 1 is generally going to have links to resources or consulting firms or additional resources that would be beneficial. Level 2 is going to have its own reporting, basic reporting, referencing other reports, buildings of similar types, estimated, this is the cost of utility, this is the reduction in it, so this is what the estimated utility cost should be, so breaking that down. And then level 3 is, okay, we have energy efficiency measure 1, 2, and 3. Okay, what's the exact impact those are going to have? So like detailed. So like if you changed your operating schedule, or if you actually installed an energy management system, to kind of control everything, what does that rate of return look like? And so level 3 is more about rate of return. I'll be going into a lot of this in a bit. But the main thing between the preliminary level 1, 2, and 3 is the amount of hours. And it also depends on the building. So obviously, if you're collecting more data doing level 3, it's going to take more hours. But you kind of think of that as an investment. Okay, so once you've walked through the building and you've collected that data, you don't really have to do it anymore. Okay, but it just varies, and you can shift saying, hey, we're only doing Freeland to level 1, and then depending on what you find out, you're like, actually, we want to go to level 3. Let's kind of see how that projects and trends for the amount of hours we got to put into it. So the process, conduct the preliminary energy assessment, conduct a walkthrough survey, identify low cost, no cost recommendations, identify capital improvements, and kind of at any point here, you can kind of get off the trail and be done if you so wish. But the further you go, the more information you're going to collect and the more clearer the image is going to be on how much energy you're using, how much it's costing you, and what the rate of return on potential energy efficiency measures will be. So that's kind of everything I've been talking about. So let's start breaking that down. Preliminary energy use analysis. This is kind of where you're just trying to collect as much information as possible, okay, regarding about the building and everyone who operates the building. So having the contact information for the facilities manager, the building owner, whoever is kind of in charge for maintaining the building, being able to have direct contact with them is important. But then floor plan sections, elevations, schedules, equipment, cut sheets, building use, utility bills. Just try to get as much as you possibly can before you commit to a site visit, because that's going to allow you to kind of get a picture of how the building was designed and how it was intended to be operated. Okay, that's important. As designed and intended to be operated. Okay, so this fourth one is also important in my opinion. Don't judge. Okay, facilities managers, this kind of a thankless job. And, the budget's not always there. They're doing the best. So you're there to assess, understand why things are the way they are, and then give recommendations. Okay. And for sometimes it takes proof of concept to move forward. So that's why the low cost, low hanging fruit is always a great option, because that's something they can do right away and they can see rate of return for it. So how do you do the PEA? ASHRAE has a template for it. It's generally a basic overview. They want your gross floor area, historic building, and delivered energy. And so here's kind of what that looks like. It's an Excel sheet. And so this goes off the ASHRAE procedures for commercial building energy audits. And it gives you basically anywhere from preliminary to level 3 is how they organize it. And if you're doing energy audits or plan on getting into doing energy audits benchmarking, buy the book. It's worth it. It's a great book. It also comes with a plethora of resources that we'll be getting into. But so then after you've done the initial assessment, you kind of want to start to figure out a roadmap or planning an outline for what the end goal is. So what is the business opportunity related to energy, cost, risk, image, etc. The design process, how much energy do we need? what is the best way to meet this? So is the building using far less energy than it's actually, than it needs? How do we kind of reduce that? What's the process? As well as evaluate opportunities. So just create an inventory of opportunities and then compare those against the energy baseline. The energy baseline is probably the most important that we're trying to get out of this effort so that we can actually have the context for what our energy efficiency measures will be. Is that going to make our system 5% better, 15% better, 30% better? Things like that. And, scale the effort. Maybe start in one space or one portion of the building, do one floor first, then do all the other floors as far as implementing the energy efficiency measures. If you want, you can go for the whole thing and do it across the entire building. It really just depends on the size of it, the use of it, and how well the facility team is up for it. So energy efficiency measures, supply options, products and services. Kind of go into the design, the organization, and how you're going to implement that. And so conducting the walkthrough survey. So the whole thing about this is trust but verify. Okay, so we trust the building was designed as it was supposed to. We trust that the building was built as it was supposed to, and we also trust that the building is operated as intended. It's not always the case. Okay, so comparing design versus as operated. So set points are supposed to be at 76 degrees, but occupants have changed it throughout the building in various spaces, 72, 74, 68. Maybe it's a little bit hotter, 81. Depending on who's using it. That has an effect on the increased cooling load or heating load, depending on how you're looking at it. Another thing, so like say facility managers, way to address that was, okay, I'm going to remove the thermostats or at least disable the operation of it so people think they're changing the temperature, but it actually has no effect on it. Well, people will generally notice, hey, it's not getting colder or it's not getting warmer. And so one of the solutions they have is to use personal heaters under their desk. And so that creates, that influences the ambient air temperature, which kind of throw off the scheduling for the HVAC, as well as increasing the kilowatt hours because that's additional office equipment that wasn't accounted for. Another one that's pretty popular is fixtures have been debulbed. So generally it's too bright. This depending on, usually you'll find us in the 80s, early 90s of commercial office buildings. They're kind of the main culprits for this, but there's just too much light. And so, people debulbing, it can have the desired effect, but generally it's just as negative as, leaving all the bolts into the fixture and turning it on. You're just getting uneven illumination, that creates contrast, glare, strains the eye, things like that. So it's just not a comfortable environment. So depending on the size or use of the building, you may have to conduct multiple walkthroughs. That's completely fine. Each time you're just refining it and you're getting a better picture, a better understanding of how the building is operating. It's also good because you can confirm data. If something happened when you visit it, you go back 2 weeks later, is it still happening? Collect data that could not be provided. So there's always going to be, you're going to have a list of questions when you're done with the walkthrough that are unanswered. And so the idea is that you go back, figure out, see if you can collect more information to answer those questions, talk to the building owner, facility manager, kind of get to the bottom of it, and then follow up and get the answer on the additional site visit. It's also a good way to collect loggers or sensors if you've installed any on the first site visit. As well as if you need to conduct a survey of the building occupants, get their opinion, if there's odd hours of operation and no one can kind of pin it down, or if, some people are coming in early, understanding, why that is, or if there's, for some reason, 1 month out of the year, building doesn't operate for whatever reason, just figuring out why that is. It's also good to talk to building occupants because they will tell you everything wrong with a building or a space. They won't tell you everything right, but they will tell you everything wrong. And that's okay because that's the information we're looking for. So if you can, ask them. If not, just leave them alone. Identify yourself, what you're doing, why you're there. Generally, people will get kind of weird when they see you sticking a tool or on a wall or a sensor or something like that, or you're up and you're messing with the lights. So always just let people know why you're there, what you're there for. And generally, they'll give you feedback without you asking for it. Identifiers of concern. Sometimes these go unnoticed as business as usual. So like, oh, that space is always cold. Oh, there's always been a draft there. Or, oh, that one's always just dark. We don't work there anymore. So things like that. So as I mentioned earlier, procedures for commercial building energy audits. This is a great book, guide, reference for anyone, whether you're a building owner, facility manager, architect, engineer. This is a great resource. And something to note, it includes 25 guideline forms plus access to the forms in spreadsheet format for easy customization. So you can print them off as PDFs, or you can make it as Excel sheets, print it off, and go back and input the data. If there's certain categories you want to add or subtract, you can do that.
Do we have that in our library, or is that something you just access online?
Yes, we do have it in our library as soon as it gets returned. Yeah. But yeah, fill. And so if you have those guides, if you're using them, do actually use them and fill them out as much as possible before you get to the site, and then fill them out as you go through the building. But generally, building information, contacts, like I said, property manager, mechanical service contractor, electrical utility representative, gas utility representative if applicable. And just, make sure you have those on hand so you can reach out to questions, and generally don't do one question at a time. Generally, have a list of questions prepared for them so they can sit down and address it, or a nice conversation can develop from that. And it's generally, in my opinion, it seems less annoying or pestering if you do it all at once rather than one at a time. You're looking for the facility description. So general, briefly describe the general condition and construction type. Know if there have been upgrades, renovations, things like that. What are the normal hours of operation? How do those deviate from standard code operating hours? That's assumed when you do contract and things like that. Does this facility have an energy management system? If so, you definitely want to go log into that and figure out what the set points are and how it's being operated. That'll give you a wealth of information. Any special notes, if there's been renovations, things like that, retrofits, if there's been additions, whatnot, just make sure you make a note of that. Another one would be like there's a large auditorium, there's a pool, there's a server room, there are 3 computer labs, there are 30 computers each. So that's something you need to document. And the annual energy consumption if you've already got it from the DEA. So, like I said, trust but verify. What do you expect to find? What did you actually find? So, determine your objective or goals by what information is missing, and divide and conquer. Having more than one person is really helpful for doing a walkthrough survey, especially for bigger commercial buildings. Also debrief. So let's say, hey, at an hour, 2 hours, we're all going to meet up and we're going to kind of share and, exchange information on what we found so far. Where, hey, I need to deploy sensors into this space, or I need to take a light level reading in this space, things like that. Like, where is it all going to happen? What data do you need to collect? And then schedule a follow-up or walkthrough at the end of it, and collect loggers, miscellaneous information. There's going to be overlap. If multiple people are doing the walkthrough, there's going to be overlap of data collected, and that's fine because that's just validation. Saying, yes, I observed that as well, or yes, I got that same reading. So let's begin. We starting inside or outside? Outside is easier because you have theoretically more readily access to it. However, you want to start where you don't have a lot of access to. So is there a certain administration portion of the building, or a server security room, or something like that? Depending on, you never really know the level of security in the commercial building until you actually get there, what you are allowed to do and what you are not allowed to do. Typically, we have those restrictions in manufacturing facilities, just because, it's proprietary, they got equipment and procedures and whatnot. But so always start there. Ask the facility manager or operator before you arrive on site, hey, what's going to be the most difficult room to lock? Start there. You want to make sure you get that, because your access is going to be limited to it. So identify any areas of space types that you're going to have limited access to, get those out of the way. And then also important, you identify any unique space types. So that's the auditorium, server room, pool, computer lab, print studio, anything out of the ordinary that would have a large load as far as heating, cooling, or kilowatt hours. And then lighting or HVAC. So between these two building systems, you will visit every part of the building. So pick one. Generally, say you have a 2,000 square foot commercial office building, 2 teams, 1 to lighting, 1 to HVAC. Between that, you'll get all the information you need for a building walking through it. So ideally, try to arrange that as you can. If it's just you, do lighting first or do HVAC first and then go do the other. So I primarily do the lighting for energy audits and site visits. So I'm going to start with that. So we're looking for the total kilowatt hour for all lighting in the building, exterior and interior. And it's broken down into 3 categories: general, accent, and task-based lighting. Not so much task-based for the exterior, but there is general and accent lighting for the exterior. And something to keep in mind when you're calculating the kilowatt hours or lighting power density or trying to quantify how much is being used by the lighting system, that it's going to be different than the code standard that was applied, because you have allowances, exceptions, and whatnot. But for the audit and the energy assessment, that you're still consuming that, this still takes power to turn on those accent lights, even though, those didn't have to be considered for when you were doing code or contract, things like that. So keep in mind that those numbers are probably going to be different. And if you apply the allowance or the exemptions to it and it comes into line, that's good. That means, we're where we're supposed to be. So where to start when documenting the lights? You want to start in the closet. Somewhere in a building, for commercial buildings at least, or manufacturing as well, there is a closet that holds all the bulbs to the fixtures. This is going to save you a lot of time because you can document each bulb before you go out and start looking at it. It also means you don't actually have to go up on ladders and poke around the ceiling grid to get that information. So visit the supply closet, either write it down, take a picture. I recommend doing both. And then what I like to do is I like to rename it for nomenclature. And so I'll have bulb A and I'll have fixture A. Okay, so like this would be bulb A and this would be bulb B, right? And this typically is going to go on a 2x4 recessed troffer. And so fixture A, 2x4 troffer, is fluorescent, has 3 bulbs of bulb A. So that means fixture A is 3 times 28. And that's going to be the watts of it. And then when I'm going to lobby, I have 4 fixture A. That's what I get to write down as I'm walking through. So if you do this organization, this nomenclature beforehand, it makes walking through a lot simpler. Okay, and the other, so you're going space by space through the building, wherever there are lights. You'll generally find one of these, fire escape, emergency exit plan, something along those lines. Take a picture of it. Not necessarily like, you should have the floor plan beforehand, but this is great in that when this was made, this is how the building was used. So you can verify, is, this computer training room still a computer training room? Is the aerobics room still an aerobics room? What has changed or evolved over time? So this is a nice snapshot of whenever it was created. Hopefully you can track that information down of how it was being used. And then, so verify the location of the space via the floor plan. I always like to have a floor plan as well as just, my sheet that I'm filling out, because I can document this space name change. This one has an occupancy sensor and it's right there. Or this has a supply for HVAC. This has return for HVAC. Or another one is taking a highlighter and outlining the floor plan where the HVAC zones are. So you can differentiate that and keep track of it as you go. That also helps when, say I meet up with Damon and he's doing HVAC and I'm like, hey, here are the zones I got. Does that agree with what you were seeing up top on the roof? And tracking the rooftop to the appropriate zone. Is the space occupied or actively used? When you walked into the space, did the lights turn on? Is there an occupant sensor that's active? No. Or did you have to turn on the lights? And there is an occupancy sensor, but because it was manually off, that didn't trip. Make those observations because that's going to impact the energy efficiency measures that you recommend. Lastly, is the sensor appropriately placed? I.e., is there an exit sign in front of it? That's where is there something blocking it? Or has a sensor been taped over so that it doesn't work anymore because someone didn't like what it was doing? Things like that. So here's an example of a fixture being debulbed, as well as something to note. I would know that there's a ceiling grid drop here, and that these fixtures are placed next to each other, and that it's way too bright for this area. So I would take a picture of that and use that as my example of please don't do this, or identifying areas like, hey guys, this needs to be rethought. So how many lights are in the space? Is the spacing consistent or is it off grid? So like this is not consistent. I don't know why this happened, what the discussion was when that happened, but these should not have been placed next to each other, at least for what the current application under the lights is right now. Does the space only have general lighting, or is there accent and tax lighting? Those are going to be summed together, but if you have those in separate categories, you can keep track of that. And so you can say, hey, you got a lot of accent lighting for as far as kilowatt hours, and we could probably reduce that. Also vice versa. Yeah, and if your client that you're doing this for has expressed interest in a lighting retrofit, then go a little more detailed. What is the ceiling grid type? What is the spacing of it? What is the height of the room? What are the dimensions of the room? Those are information that is going to be necessary for the architect or electrical lighting designer to repurpose the space and respace out the fixtures and figure out the lumen efficacy that's needed. So if they've expressed that interest, go ahead and collect that data. It's there and it will be available. Are there additional control systems present in the space? So daylighting. If there is, and you want to test the photo control to see if it's working, having a flashlight, shine the flashlight on the sensor, that's going to tell it that the lumens have increased dramatically and it should reduce the electric lighting. If it doesn't, then something's wrong. Shades or blind operation. So if your space is meant to be daylight, you see the photo control sensor and it's daylight outside, but all the blinds are down. Ask the occupant why. Is that normally the case? Or is it just like, hey, there was some glare because a car was parked there, so I wanted to drop the blinds. Quality control, asking the occupants their opinion of the lighting scheme. Believe me, they will definitely tell you what they like and they don't like, in my experience. Another one that is kind of put to the wayside would be color temperature. So if you're looking at a fixture, or at least an open office area, and you see a row of fixtures, is the color consistent throughout it? Okay. And then how do occupants interact with the lighting system? So is the main light switch for the open office area around the corner and out in the hallway, and we got to turn that on. And there's no occupancy sensor, so those lights generally just stay on 24/7. So things like that. Or is the lighting, the light switch appropriately placed and it's readily accessible and people have no problem getting to it. Quality control, using a light meter to document lux or foot candles. Here in the US, we primarily deal with foot candles, and any of the manufacturers or Illuminated Engineering Society recommendations come in foot candles. So to take measurement, you generally want to do it at the work surface. So generally I'll have a stool I kind of carry around depending on the space of the area, but if I'm in like open office or private office, I'll put it on the desk because I want to know what the perception of light is when I'm sitting at the desk. Another thing to note is whether you're taking it on center, off center, or away. So on center means you're directly below the light, off center means you're on the edge of it, away means you're farther out on the perimeter. And so I'll tell you, how the it's not Candela distribution. I'm forgetting the American one. It'll tell you how the light's being distributed in the space and how effective it is. And that's good for also noting the efficacy of the light, how efficient it is, how much degradation has happened in its lifetime. So like this like blew me away that I saw this in a space. There's so much light for that one little desk there, and so much power being wasted. So sometimes to me, like, that's obvious. I can tell it, no problem from my experience, but I will still put a light meter there. I will take the measurement because I have to prove and verify that that is what's happening. It's always easier to do with scientific data. While you're there, we're not just caring about the lights. We want to document equipment, computers, monitors, refrigerators, ice makers, vending machines, dishwasher, personal heaters, etc. We kind of just want to know. Any additional HVAC units or supply, make a note of that. If you want, you can make a note of where the supply and return ventilation is located. It's helpful but not necessary. You should make a note of where the thermostat is located and what set point it is at. And then for the most part, you're just gonna rinse and repeat. There will be exceptions that require some unique documentations, but generally, for the most part, that should just be what you're doing as you go space to space, kind of documenting it. Now, as far as, before I get into the HVAC side of it, as far as like taking light level measurements or measuring rooms dimension and things like that, you generally only need to do that 25 to 30% of the spaces. And of that, you want to make sure you get the, I guess what I would call anchors, like the big ones. So like if you have an open office area that's 3,000 square feet, okay, take quite a few lighting measurements in that, measure the dimensions of the room and whatnot, because I'll just verify the accuracy of our floor plan that we have on hand, as well as, okay, that's the cut sheet for the lights that were installed. They have, manufacturer says there's supposed to be this much output at this power percentage. Does that make sense for what it's designed at? If we're starting with HVAC, before I get on that, I guess, does anyone have any questions? And we're kind of almost at time. Okay, I'm gonna kind of skip over the HVAC a little bit. The important thing about the HVAC is the outdoor air temperature. We have sensors for that. I'll go over all that a little bit. Intake air temperature, data logger with current transformer, and the state pulse logger is generally what's being considered as a data logger. So that takes vibrations and will log that. And so that's generally when the rooftop unit is kicking on. And then the current transformer is to validate that it is kicking on when it said it is and how much power is being drawn. And so that'll give us an idea of how it's operating, if it's operating on the schedule it should or if it's not. And then having a data logger regarding air temperature, humidity, and if you want CO2 or VOC as well for the supply and return, make sure it's zone appropriate. Okay, so you want to make sure the rooftop unit that you're monitoring is that you're also monitoring the zone that it's supplying. And then also data logger for the thermostat. Next to the thermostat, we're kind of just verifying that the thermostat is operating as it should. So if it says it's 72 and we put a sensor next to it, it's installed and reading, it should also read 72. So here's kind of tools for documentation. I brought a lot of these down here. I'm sure you all are familiar with it. Can you see online for this at all?
No, you're just upgrading.
Yeah. I got some over here.
Sort of. It's pretty small. It's tough to see.
Throw the thermal camera down that we have. We got an IR thermometer for surface temperature reading and whatnot. We got a CO2 logger. Down with our outdoor sensor. You kind of hook them up and just set them on the roof, and it's fine. It's weatherproof, so it's good for that. And that kind of verifies the weather file data that if you're using any, if it's accurate to your area. Light meter here. The light meter, you want to open it up. on the table. Don't take off the cap, turn it on. It's a validation metric, so if you turn it on and look at it, it should read 0. And so it is. You're gonna take it off, and then you're gonna step away from the light meter sensor, okay? You yourself interact with how light, interacts with the space. So you're gonna do that, and that's why I brought this dial with here. Just look at it, let it hold. And so this is saying 523 lux. Change it to foot candles. It's reading at 48 foot candles, which is appropriate for the classroom. So yeah, I got pretty much rest of it is just you show them off the tools. We got a plug logger, current transformer, current plant, current meter. My favorite latest ones, we have occupancy sensors. So if you want to identify what the actual occupancy schedule for a building is, you can get a pretty accurate idea of it and then put that into your energy model. For instance, yeah. Any questions?
I had a quick question.
Yeah.
Is it common for residential building to request energy audits?
No. We primarily deal with the commercial side of it. I guess I should make that note. Idaho Power customer, commercial, residential, doesn't matter. If you're an Idaho Power customer, you have access to the library. So I've had people take it for their personal homes. They want to investigate, air quality, or they want to see how their windows are sealed, and if they need to do weatherization, things like that. I don't think have we done a full energy audit for residential home before?
No, I mean, the intent of the library is mainly for commercial,
Yeah.
Yeah, that makes sense.
but we occasionally get checkouts from
I mean, if you're up for it,
BSU who are doing investigations on air quality and want to measure their duct velocity and things like that. So
I checked one out for my house once. Thermal came.
it's fun.
That's
great.
But your OEMR walkthroughs, those are just commercial as well, right?
They are.
Yeah, and they're typically limited to civic commercial, so like library, city hall, facilities, parks departments, schools. Yeah.
Of the state, but that's been kind of the main use of the ERL lately.
And I would also note that a CO2 or VOC logger is essential when auditing a school, so that you can prove to them their air quality is bad and it's not good for children. They should improve it. And we found that that's generally an unfortunate trend we've identified.
But of
What's
course, our
your
college
VOC
buildings are much better, right?
Which VOC logger do you use?
I can't show you. We have a couple different brands. So I've managed over the years since I've been managing the library to kind of narrow down the manufacturing and just go over it. I hate this. I need one browser, not 3.
Choices, people like choices.
We also have
I made the choice, which is the one I have open. So why is it open the other ones? Oh yeah, we got a O3 monitor recently. We have the capture hood flow kit. Since Crowder, here we go. I think it's Pappy. Yeah, Pappy is we got. And then
it measures it in CO2 equivalent, basically. So it doesn't give you a breakdown of exactly what particles it is measuring, whether that's from carpet or paint or something like that. It just gives an approximate amount and correlates it to CO2 parts per million. Yeah. So it's not like the most detailed, but it can pick up things that CO2 monitors don't.
it'll be
Light paint is one example. Like we measured it in the building, and it was just off the charts for the VOC, but it was in an unoccupied space, and CO2 was dormant, but people were complaining about fumes. We found out, paint was there was renovation happening a few floors down. It was going up to the chase and getting sucked in there. Yeah.
It could also just be an indicator that you have doing basic walkthrough analysis, and you find this out, that your levels are higher than what they should be, and so that prompts a more specific investigation into the off gassing. Like you said, go find out where the pain is coming from. So yeah, anything else? Any online questions?
Yeah, I opened up the chat, but haven't heard anything.
Okay.